6/9 now. Didn't make any mistakes there, did we? Hey folks, welcome out there to T and Learn Mathline. I'm Ernie Roberts. I'm your host for this afternoon's session of Summer School. Yes, T and Learn Mathline Summer School. And you know what? It's a great time to sit back, relax, learn some math. We're not live on the air, but you can still send us questions through Facebook and also, of course, email. We love to hear from you. But today is one of those days where you get pencil, paper, and let's sit back and do a little math, a little review of some sort, because that's what summer school is all about. Remediation, review, getting you ready so you can knock the top out of next year's fall, August, whenever you want to call it, when you're going back to school, ready to knock the top out of that schedule next year, all right? So let's see what's going on. What are we going to do to remediate and review and have fun with today? It's fraction action. One more round, a fifth part, division. And again, just fractions, not necessarily getting into the mixed numbers per se, but we're going to play with the fractions and all right? So enjoy the concept because, you know, you can't divide fractions, can you? Basically, it's like playing with multiplication, all right? So if you know how to multiply fractions, one little rule is going to make this an easy day for you, all right, to remember what to do. If you haven't done fraction division before, it's easy to learn how to do, all right? And if you know your times tables, I keep saying that, don't I? Even easier, even easier. So let's go and see what kind of problems we are looking at right here today, all right? Start off with actually a rather interesting one. Why in the world would I start off with 12 divided by 2? Because I want you to think about when we divide by 2, and notice that problem next to it says divided by a half and then by a third. I want you to understand the difference, all right? When we divide by 2, we're basically taking half of 12. Well, you've been doing division probably since second and third grade, all right? Well, once you learn some of your multiplication tables, you begin to do division. So second grade might be a little extreme, although some of you were probably already doing it back then. But third, definitely fourth grade, you start hitting on the division very, very intensely. Then we start worrying about, well, what happens when we start dividing by a fraction? So I've got the same idea here. I've got the same number. Let's talk about a big cake that has 12 blocks in it, okay? And I'm going to divide it by 2. In other words, I'm going to have 6 blocks going this way. It's a good bit of cake, isn't it? Delicious stuff. And 6 blocks going that way. That's what we mean when we divide by 2. We divide in 2 sections that would have 6 each. So when I go to the point of saying 12 divided by 2, I'm actually going to get the number 6. Now please understand, this does not mean the same as this. This says I'm going to take that 12 blocks of cake already and I'm going to divide each of them into halves, and I want to know how many are left, or how many do I have actually, not how many are left. We might eat a few of them, you know, get hungry. But how many would you have to serve there? And if you divide each of those 12 into halves, divide by a half, all of a sudden you've got double the amount. You've got more people you can feed, all right? You got 24 that you can feed there. So you say, well, Ernie, what's the deal there? So let's talk about it. Let's talk about it. Well, what is the deal? Because I just told you 24. And if you want to really get crazy, how about it? Divide those 12 blocks into thirds, and you're going to have 36. It's crazy, but that's the way caterers do it all the time. They try to make sure they can stretch things, and if you're having a big party or a big reception, you want to stretch your food. You cut it into smaller portions. You half it. You third it. You might even go into fourth. My goodness, if you did fourth, guess what? You have 4 times 12. So what I want you to see from that little illustration is, what's going on here? Well, what's happening is we're saying, on the first one here, we're basically saying 12 times 1/2, times 1/2. And if you remember, when we put a 1 under that 12, that's where we come up with 6, because we're basically saying 12 over 2, it's a fraction. I mean, it's arithmetic. There's no way to make this thing too fancy. But I want you to see how it works versus this. Here, what we wound up doing was changing from division to multiplication. That's the game plan for all of our fractions. When we have division, we've got to make it go to multiplication. You say, well, Ernie, oh yeah, Ernie, I see what you did. Some of you may still not say, Ernie, I don't see what you did there on the next one. Here we used the reciprocal of 1/2. We said 12 times 2, because that's how we had 24 pieces at the end, all right? Here we said, 12 times 3 to get 36. So the deal is, when we go multiplication, we make a reciprocal. You say, well, those are both integers, or those were nice whole numbers. We can put ones underneath there. Put ones underneath there. And that's what's happening. And you say, well, that's not that difficult. We could have done it without doing that. Exactly. Again, the process works for integers. It works for fractions. It works for any rational numbers. The concept of what is division by a fraction or a rational number. So here we go. Let's take a look at how we got 24 out of this one. We go, and I'm going to draw a line down here so we don't get confused. Let's see, we've got times reciprocal 2 over 1. Now remember, 2 over 1, that's the reciprocal of the second. I didn't make a reciprocal out of 12. Didn't make a reciprocal out of 12 here. I just put a 1 underneath it. That just simply I made it rational and look like a fraction, easier for us to see where we're going with it, all right? And by the way, what does that give us? That does give us 24. Whereas this one over here gave us 6, all right? So there's a big difference. Oh, a big difference when you divide by a half versus when you divide by 2, all right? Now what about here? We're going to take our 12 over 1 once again, and we're going to use a reciprocal. We'll make multiplication out of this. And we're going to take 3 over 1, and guess what? It gives us that 36 right there. So there you go. That's the process. And as I said, I use this as little cakes or little pieces of something. You divide it halves, all right? You've got double the amount. Here you go. Here you divide it into thirds, each of those pieces. You've now got 36 pieces. Over here, you just took your 6 pieces and you split them into 2 groups. That's the difference. That's the difference, all right? So that's our story today, division of fractions. And we always want to make sure we simplify, right? We came out nice whole numbers. It's kind of interesting, easy working for us there. Let's see if it always happens. Sometimes it does, and sometimes it doesn't. Now this set, it's going to go back again the same way. Let's think it back in. We're going to say 15 divided by 3. You've been doing that for a long time out there. Basically, how many times does 3 go into 15? That's easy. If I want to make those into fractions, it's 15 over 1 times, remember, reciprocal. And why did we make 1 over 3? Because it's 3 over 1, 15 over 1 here, all right? So that's a reciprocal approach. And yes, oh, by the way, did I mention? You can cancel. Multiplication allows it to cancel. Don't cancel until you're multiplying, by the way. You can't cancel with the division moments, but you certainly can in this case. So let's see what happens. I get a 5, and I get a 1. Answer is 5. And we know that. 15 divided by 3 is 5 for sure. Now, things get a little different here. I'm taking that 15. I'm going to divide it into thirds. So it's like saying 15 over 1 times reciprocal, folks. Reciprocal, yeah. Nice big R word. It's good to know that. Some people hear the word invert. That's all right. Invert, that's what you're doing. You're basically not regrouping per se, but you're rewriting numerator and denominator here, all right, into different places. The 15 over 1 stays the same. The only place we go with a reciprocal is this little guy here, the second term, what follows the division marker, what follows your division, all right? By the way, 15 times 3, we pick up 45. Whew, that's a lot of pieces. If we're talking about cake, or maybe we're talking about dividing punch or other good things, other good foods, sandwiches even, into thirds, all right? You get the idea. You're going to have a lot more to work with. Here, let's go back to 15 one more time. And let's make that 15 over 1 divided by 1 over 2. I want to just make a point right here. Again, remember I said don't try to cancel? Well, you can't with 2 and 15, all right? But back over here, if you'd had 1 over 3, you can't cancel right here, okay? When you put a 1 under that, you can't cancel that 3 and 15. It's a direct horizontal multiplication when you use a reciprocal. So don't try to cancel until you're in multiplication mode, okay? Now, what do? We do 15 over 1 times, guess what? Reciprocal, 2 over 1. And folks, we are at 30. These ones are basically immaterial because they're in the denominator. If they were in the numerator, they would be important. They would be very important. They have to stay in the final answer. Here, we just basically go to a nice whole number. All right, and by the way, that whole number is also rational. It can be written as a fraction, 30 over 1, if you so choose. I think we all like to see 30 by itself. It just seems to be easier to deal with. So let's take a little bit of practice here with these things. All right, we basically picked up the number here. If you look at the next problem here, we got going. Got 6 divided by 2/3, and we have 1/6 divided by 2/3. Now there's a difference, obviously, a big difference. Folks, this is 6 over 1. You write that down at home. And this is just simply as it says, 1/6, or 1 over 6, or 1 divided by 6, divided by 2/3. Now we're divided by 2/3 both times, but we're going to get a most dramatically different number, all right, by doing what we've got here, where we're starting and where we're going to finish. So here we're going to take 6, and we're going to divide by 2/3, which means we're going to multiply, yes, you got it, multiply by 3 over 2, 3 over 2. Remember, drop your 1 under that 6, keep you straight. That's how we do integers. We make them rational, putting a 1 underneath there. And let's see how we clean this up. We're going to divide 2 into both of these, which gives me 3, gives me 1 here. Woo! 3 times 3 gives me 9. I'm over 1, so we leave it at 9. That's very straightforward. That's very straightforward when we work through that, all right? Now, what happens over here? We start with 1/6, which is a much, much smaller piece, all right? 6 versus 1/6, it's a big major difference. Big major difference, all right? So we're going to multiply just like we do before, though. We're going to go ahead and multiply by 3 halves, or 3 over 2. Now notice we did not change 6 over 1 here. We did not change 1 over 6 here. Only what follows after the division marker. Now you can do your multiplication as you wish. Well, what do you want to do with it? Well, Ernie says, let's do this. Let's see, we've got some cancellations. So how about it? 3 goes into 3 one time. 3 goes into 6 2 times. I see 1 on the top in the numerator land and 2 times 2 in the denominator for 4. And again, that 1 is important. Don't lose it. Over here we had 9 over 1. That's not an important moment. You can leave that 1 out. This one, you got to keep it. You got to keep it because 1/4 is a big difference than having 4 of something. Having a quarter versus $4, think about it. That's a big difference, all right? So again, as we work through these, always be wise. You're going to change division to multiplication and use that reciprocal. And of course, simplify. Now, you say, Ernie, what if we hadn't simplified? Well, you would have had 3 over 12. But you still would have simplified, right? You all know that because you would have had to divide both of these by 3. Because it says simplify, reduce, however you want to look at that. And that would give us the 1/4 once again. So you can avoid those cancellations, but I think they make things easier. And also, when the numbers are smaller, usually you are reduced if you've done your cancellations correctly and done them thoroughly. Okay? So that's our story on dividing and simplifying. How do you start? How do you finish? And the reciprocal gets you where you're going. Let's take a look at another situation here. Let's take a look at these little problems here. Here we start with the same place, but we divide by different values here. And again, we're going to get different answers on these two problems, okay? We're going to get 2 different answers. So let's start first with 3/4. While you're at home, write this down. Go ahead and put a 1 under the 8. This is where it's going to be helpful to us to have that 1 under the 8 because we're looking for the reciprocal of 8. And folks, the reciprocal of 8 is 1 over 8 or 1 divided by 8, 1/8, if you will, all right? So we got 3/4. We're going to multiply that times 1/8. And you say, Ernie, I'm glad I didn't try to cancel because you can't. You can't cancel that 4 and the 8. There's a division marker here. Don't do it. That's why we got to go to multiplication. And if you'll notice, the 4 and the 8 don't cancel. You can't cancel. You cannot cancel horizontally. All we can do is multiply. So the answer for this one, how about it? 3 in the numerator slot, 32 for your denominator. We're done. So we basically took 3/4 and we divided it 8 ways. That's going to give us small pieces, very small pieces as a result. Now over here we're taking that 3/4 and we're going to divide it into eighths. And we want to know how many sections do we have. All right, it's kind of what we're looking at. It's not pretty. I'm going to go ahead and tell you it's not very pretty, or is it? We'll see. Let's check it out and find out. Maybe it is pretty. You know, things get interesting here. I believe it actually might be a pretty answer. Everybody's going, what do you mean pretty? All right, let's see. Take 3/4, and this time we already are in a fraction form. So let's go ahead and we'll rewrite it. So while y'all are writing at home, I'll rewrite it right there for you. Let's now go reciprocals. Let's do the reciprocal. Now this time, life's a little sweeter to us. This time it is going to be pretty, because look what happens. This 4 and this 8 cancel this time. See the difference? You have to wait until you get to multiplication mode to see if you're going to cancel. And the ones, they're fine on the bottom. That tells me we're going to have a nice integer value here. And it's going to give us 3 times 2, giving us 6. Whoo! A big difference here. A big difference there, all right, between 3/32 and 6. Boy, think about money in that respect. So again, it is important you understand what's the process we're going to do here, all right? So as we look at these division problems today, that's where we're after, all right, is to make sure you can see the distinction. We start at the same place, but we divide it in a very, very much of a different manner, all right? Different mannerism there. Now, let's see what we got going on our next one. Dividing and simplifying. When we are constantly thinking of simplification, I'm simply saying let's reduce them down to the lowest terms. Simplify the lowest terms. So let's take a look at our next one here. And this time we're starting again with 2/3. This is just good practice. And we're starting here with 2/3. We're going to let you write those down, all right? Notice here we started with 3/4 as our divided moment. Over here we're going to divide by 4/3, all right? Reciprocals, I'm really interested to see what the answers look like on this. Should be an interesting moment here, all right? They're not going to be the same, we know that, right? So let's go with it. 2/3 times, how about it, 4/3. Boy, some of you thought there's going to be a lot of canceling on that one. Absolutely not, right? Absolutely not. Your numerators are going to work together. Your denominators are going to work together. I see nothing going horizontally. Well, we can't cancel horizontally, can we? We can only multiply. I see nothing going vertically. That's where we can cancel. And I see nothing on the diagonal. We can't cancel there. So we're stuck. The only options we have for canceling, folks, are in vertical fashion or on the diagonal. Remember, can't take these 3's out and can't do 2 and 4. We've just got to multiply. So let's do it. That gives us 8. 3 times 3 gives us 9. That's where it ends up. So be careful, be careful, be careful. Now over here, life is a lot sweeter. Here you are actually, it looks like, well, we couldn't cancel. We couldn't try to. If you looked at it as this, if you wanted to try to cancel, remember what we said, we can't do it horizontally, right? We can't cancel anyway because we're still in division, all right? But let's see what happens when we go to that reciprocal. Lots of things loosen up. Lots of things break out here. The 3's, say goodbye. The 2 and the 4, say goodbye. Well, keep a 2 down there. And keep those 1's up on top, all right? Because they're important. 1 times 1 gives us 1. And here we go, 1/2, all right? So that's our story here. That's what we're looking at. I want to make sure everybody understands how important this reciprocal moment is. And by the way, notice we kept 2/3 because that's where we start. We can't change that. So we start. This is where we go. All right? We keep the 2/3 here. This is where we go, is to the 3/4. So that's important to notice. We have a starting point and, of course, a finishing point. And as I said, they're distinctly different fractions there. Distinctly different. So be careful. Be careful when you're doing these problems. Follow the order. Follow the order. Reduce somewhere in there if you can. 8th, 9th, you couldn't. Over here, the 1/2, we were able to do quite a bit of cancellation that allowed us to reduce things down. Easy problems? I hope so for you, all right? Hopefully these are not overly challenging. Good just to remember, just to review, and have you back on track for next year. Wow, keep saying that, don't I? Let's see. I think this one I've got here looks like a little bit of repetition. Let's go to this one. It says divide and simplify. How about it? Ooh, Ernie, you finally get some big numbers there. I want to make sure we know our times tables, right? That's so sure. That is so true. So let's see what happens. I've got 12 over 11. Let y'all write this one down. And 11 over 12. It's divided by moment. Now, this little guy over here on the other side has a real interesting look. And I'm hoping some of you are noticing something about it. Looking ahead. I know. All right, let's play this thing out. Boy, if you were just crazy about canceling, you'd probably try to go, oh, 11s and 12s, but Ernie Roberts did not mean for you to do that. No, not on that problem. Remember what we have to do. Before we can cancel, we've got to go to multiplication. We aren't there yet. So don't give in to that temptation. Do not, repeat, do not give in to that temptation. Let's keep the 12 over 11. I guess you call it 12 elevenths. That's an interesting phrase. 11 twelfths is a little bit easier. That's what we're going to divide by, all right? So here's what we want to do with the 11 twelfths. We're going to use the reciprocal. We're going to use the reciprocal, which is going to be times 12 over 11. Didn't say it was going to be pretty, folks. I did not say it was going to be pretty. Now we have to drop out the bottom third here for the first time in this show. But let's see what we got. We got 12 times 12. Thank you, guys. They're ahead of me. I get 44 in the numerator. Those you wanted to challenge, here you go. Here you go. In the denominator, we got 11 times 11, which is going to give us 121. 121. Wow. Okay. It's improper. Let's do some mixed numbers on it, all right? Good news is it only goes in there how many times? Everybody count it, check it, what have you. It goes in there one time, right? And what have we got left over? Woo! At least I didn't make hard subtraction, did I? Subtraction's pretty easy on that one. Because what's going to happen is we use 121 out of that. We've got 23 left. And that is out of 144. Not very pretty, is it? But I'll tell you what, if that had been 24, over that, this fraction would have dissolved down very nicely. Would have dissolved down very nicely, reduced. Wow, 24 will go in there to 144. I believe it would have gone 6 times. So it's almost 1 1/6 here, all right? That's where we're getting pretty close. That's where we're getting pretty close to almost 1 1/6. So again, when we look at something like this, sometimes it's nice to think, okay, benchmark fraction, I can get a handle on where that is. It's very, very close to a 1 1/6. Now, the other side, which I told you all about, these 12s and 11s. I love 12s and 11s. If you notice that, let's rewrite it. You get to do that at home. And this one's one where you're going to say, put it down right, otherwise we're writing the problem down again. Here we're going to take and make our division go multiplication, right? And we want to use reciprocal. So let's see what happens. We got 12 over 11. We're going to multiply that times 11 over 12. This is the one everybody can go and take some good cancellations on. All right, this one's pretty because you've got the 12s that are canceling out, gives you 1s. Don't lose those 1s. They're important. And here we go, 11 goes in there 1s. And sometimes a few of my students will sit there and say, there's nothing left. Well, not true, not true. There is something left in this problem. There are a lot of 1s. There are 1s left here. 1 times 1 gives you 1. 1 times 1 underneath gives you 1. Hey, we're just going to call that 1. And that, folks, is a good answer. It's a good answer. Now let's go back and look at that thing. Notice we were saying 12 11ths divided by 12 11ths. So it doesn't matter how crazy the numbers are. If you take an expression, in this case, 12 11ths, and you divide by the same thing, 12 11ths, it's the same thing as taking a number divided by itself. It always equals 1. So truthfully, that's what happened when we do the reciprocal, all right? And the reciprocal made it work beautifully. Notice that. Everything canceled except 1. And our final answer is that, 1. There are no zeros up there. No zeros. So the answer is not 0. Answer comes out to be 1. This one over here, like I said, wasn't quite so pretty because we were worrying about, wow, what's 12 squared? 144. 11 squared, 121. And then we had to do a little division. And you know what? Let's fix something right now. Almost had a mess up here. I did have a mess up. Some of you are already going like, Ernie, don't you know how to reduce a fraction? Yes, I do. So let's put it 1 in 23 over 121. 121. Thank you, Mathline folks. You all are very astute. And that's even worse. And that's why we go back and recheck, because something looked wrong about that. My goodness. And every one of you were saying, Ernie, that's a bad moment. All right. So we go back and recheck it. And, you know, it's not 1 1/6, is it? All right. So hopefully that didn't confuse anybody out there. But again, it makes you realize we've got to look close, especially when those numbers get big. Got to think, what's the context? What's going on? Hey, thanks for tuning in this afternoon. Hope you've had a little bit of fun with me, a little fun at me on Mathline Summer School. We'll be back again next time, and we'll see you then.